So we are going to start with the SciLab introduction and programming. SciLab, as you know, is an sir has already told that SciLab is an alternative of MATLAB. MATLAB stands for Matrix Laboratory, and SciLab stands for Scientific Laboratory. So as MATLAB is dealing with the matrices only, means we are inputting the data in the form of vectors or arrays. So similarly in the SciLab also, we are entering the data in the form of matrices. And the same manipulations is being done on the various matrices that we are going to do. So in this SciLab we can do the programming on neural networks, on image processing, we can optimize, and then there is a toolbox also as in case of MATLAB also. And but the main advantage of SciLab is that it is open source, means it is openly available at the internet. But for the MATLAB you have to buy MATLAB and it costs a lot. But the SciLab is freely available, and you can also, means it is open source code, means its code is openly available to all. You can even modify the code according to your application, and also you can add to the modules also. So in case you make your own module, so you can also make that. You can add to the libraries also. So it is very much similar to MATLAB, but and also as much powerful as MATLAB is. So it is very useful for the students for the research purposes, because for MATLAB, as I have seen in many colleges, the MATLAB which is used is pirated one. So we can't claim it in our reports that yes, we are using MATLAB. But SciLab, for the SciLab, that is solving our purpose also, and also we can claim that yes, we are using SciLab. Now, as in similar to MATLAB, it handles the matrices as we do basic operations in MATLAB, manipulation, concatenation, transpose, inverse, etc. And also the numerical computations, same will be done in the SciLab. And we can also create our own functions as we do in MATLAB. I think you all must be familiar with the MATLAB. Basics of MATLAB, I think you all are familiar. So we can view and modify the source code and improve the source code also, and use the code for our own project. Now how to install? It is available on the site. So go to the site www.scilab.org. So go to the download section, and in that section find the right version of your operating system, Linux, Windows, which bit is there, 32-bit or 64-bit, according to your requirement of the system. Download this version of the SciLab, and as we download, then save it, then run the setup. In the same way we install the other programs, right? In the same way we have to install the SciLab. Now this is the SciLab console. If it is visible to all the centers. So here is a SciLab console. Means the SciLab console is where, as it is similar to the command window in this MATLAB. Similarly, in the MATLAB there is an editor window. In the editor window, what we do? We write our program first, then we run from that, and then the result is shown in the command window. Similarly, in the SciLab, that is called as, means the same window is there, but the name is, this is given as name is SciLab Notes. SciNotes. Editor window is here in SciNotes. And there is a command history window also, and the variable browser also, means the variables which are being used in the program, that has also been visible on the separate window. So all these 3-4 windows are separate. When you will download, you will get all these windows are separated, but you can dock these windows on the command window also. So the look will be like as you are seeing. So the common operators which we can do on the matrices: addition, subtraction, multiplication, division, power, and conjugate transpose. As you are seeing, plus is for addition, minus, star, this is for multiplication, slash is for division, all these. So means this is the similarity which we are saying, that operators are also same as in MATLAB. Because what we are claiming that yes, SciLab is similar to MATLAB. And the common functions sine, cos, tan, a sine, a cos, a tan, absolute is for ABS, minimum, maximum, square root, and sum. Means these are some of the basic functions I am showing. So if we want to do sine of 0.7, do it like this. Sine within bracket 0.7, then the answer will be displayed like this. 0.6442177. Means this much precision will be given by the SciLab. Next is maximum of 2, 3, absolute of -5. Maximum means we have to find the maximum of all these three. So what is the maximum? 5. Absolute of 5 means 5. So the answer is equal to 5. Now the special constant. Here is some slight difference with the MATLAB. In the MATLAB what we are doing? If we want to use pi or complex number, we are using I or E for the complex numbers, and for the pi we are using pi. But at other place we can't use that pi because that is a special constant, we can't use that. But in SciLab we use the special constant by prefixing percentage on it. So for using pi we have to write percentage pi, percentage I, percentage E like this. So percentage means now it is a special character. When we will write percentage pi means the value returned will be 3.14. Pi की value क्या होती है? 3.14. So that will be returned. But in other case, if we are using complex number I, then I will write percentage I. So I can also use I as a variable also. Understood? Means I am using percentage I for the complex number and I for the variable. So at the same time I can use both. And for the logical operations we are using true and false. Here in MATLAB it is 1 and 0. It is written as percentage T and percentage as F in SciLab. True or false. Now the matrix construction and manipulation, and I hope everybody is familiar with this, but still we are covering it. So first we have to write A is equal to, anything we have to enter it in square brackets only, right? So A is equal to square brackets, within square brackets 1, 2, 3, 4, anything we can write. So this is a one row matrix, right? If we want to add another row, put semicolon, then write the data. Then semicolon, then write the data. Means after the semicolon, the program is taken to the another row. So means if I am writing 3 rows, I have to put in semicolons in between them, right? So A is equal to 1, 2, 3, 4, comma, or you can give space also. If you give space or comma means another element is going to be there. So the answer is A, 1, 2, 3, right? So if you put A is equal to within square bracket 1, 2, 3, 4 and after that you put a semicolon, then the result will not be displayed on the command window. Okay. So if you want the result to be displayed, if you don't put semicolon only, then it will be displayed. Otherwise you have to write the command disp DISP for the display. Similarly, next example is A is equal to 1, 2, 3 plus 5. Means now the first two element is 1 and 2 and the third element is 3 plus 5 means 8. So the answer is 1, 2 and 8. And similarly third, you can see the third element is 3 into 5 is equal to 15. So this is means we have entered the data. Now these elements are being stored in the variable A. A को हमने assign कर दिया एक variable और उसमें हमने सारा data जो है अपना store कर दिया. Now this is another example of inputting the data or making a matrix. A is equal to, within square bracket we are writing I, 2, 1. 2 means 2, 1 means 2 rows and 1 column. I means only one diagonal matrix will be there having 1. And comma 3 into 1s 2, 3. 1s 2, 3 means a matrix of 2 rows and 3 columns will be generated having all the elements equal to 1, right? Then semicolon lin space 394. What does it mean? We have to generate a matrix starting from the element 3 going up to 9 having 4 elements. Then zeros 1, 4. zeros, 1 row and 4 columns, we are creating zeros. So the matrix returned is like this, as you can see, A, 1, 0. 1, 0 is returned from the syntax I 2, 1. Then 3 into 1s means in the same row you are taking 3 into 1s 2, 3 means 2 for the 2 rows you are generating 3 columns. The first column is from the I matrix and then the second from the 1s matrix. And then we are putting semicolon. Mean now it is going to the another line with the 3, 9 means 1 row is there, right? 1 row is there with 4 elements starting from 3 to 9. As you can see, 3, 5, 7 and 9. Then zeros, 1, 4 in the another. Because we have put semicolon, it will be going to the next line. So zeros, 1, 4. Now diagonal of an element, if you want to take, D is equal to diag, D-I-A-G-A. Then it will return the diagonal starting from the left upper side to the right down side, right? So it will return 1, 3, 7 and 0, as in this case the diagonal is 1, 3, 7 and 0. Similarly, we can also generate a random matrix. Random matrix having numbers which are randomly generated between 0 and 1. So A is equal to rand 2, 2 means a random matrix of 2 rows and 2 columns will be generated whose elements lie within 0 and 1. The next is B is equal to exponential of A. EXP means exponential of A will be calculated of the matrix which we have, which is there in the variable A, right? So I am not performing it on the SciLab because I suppose these are the basic functions and you can do it, right? Or you want me to do it? It's okay? Okay. Then calculating sums. Sums, it's for plus. So for a square matrix, M is equal to 8, 1, 6, 3, 5, 7 and 4, 9, 2. This is a matrix we have entered. What is the size of this matrix? 3 cross 3 means 3 rows and 3 columns are there. Now if we want to find the sum of the columns, then how to write? Sum within round brackets, name of the matrix M, comma, within single quotes C. C stands for columns, all the columns. So this syntax will find the sum of all the columns. We are having 3 columns in the matrix M and the answer return will be 15, 15 and 15. As you can see, the sum of all the columns is 15, right? Similarly, if we want to find the sum of all the rows, then sum M, comma, within single quotes R. So similarly, we will find the answer is 15, 15, 15. So this matrix is usually called as magic matrix because we are getting sums of rows and columns equal to 15. Now how to find the sum of the main diagonal? Main diagonal, as I have already told you, it is from the left upper corner to the right down corner, right? That is the main diagonal. So in case we want to sum, then diagonal M, that will give us 8, 5, 2. Means the elements of the diagonal are being returned. Then if I write sum within round brackets diagonal M, then the elements returned by the diagonal M will be summed up. Now if we want to find the sum of the diagonal, other diagonal means the starting from the right upper corner right, as you can see M1, 3 plus this. This is some first method to find the sum of a diagonal. There is another method to find the sum of a diagonal. There is a command flip rows and columns, flip rows, right? So that can be used in the SciLab using the syntax. That is the syntax or the command in the MATLAB. So we can use this command in the MATLAB by using the syntax mtlb underscore flip.lr. Means this is a MATLAB command, but we are using in the SciLab by prefixing this mtlb. So similarly, there are many other commands which are there in the MATLAB. So we can call them in the SciLab using this mtlb underscore this. So now when we flip the rows and rows, then we can use the same syntax which we did for the main diagonal, because we have now flipped the elements, right? So the desired result would then be obtained by typing sum diagonal mtlb flip rm. किसके flip किए हमने elements? That name we have to write, that is matrix M. Then we have to take the diagonal, then we have to take the diagonal elements sum. Now the command line. The command lines, multiple command lines are separated by commas. If we are writing comma and then in the next line it will be taken into the continuity form. Means the same line is there, and it is same in MATLAB also. So multiple commands separated by commas can be put on the same command line. So A is equal to 1, 2, 3. This is one matrix. X is equal to 10 pi by 4 plus E. E is some complex number is there. So A is this, S is written like this. And entering a semicolon, as I've already told, entering a semicolon at the end of a command line suppresses showing the result. Strings. Now to enter a string, enclose it with either single or double quotations. Example, this is a string or this is also a string. Means within single quote will be also taken as a string, and double quote you can write in both ways. And to concatenate these strings, concatenate means you have to join the words, then you have to use the operator plus. Here the plus operator will be used for the concatenation of the strings. It is also used for the operation of summing, but here with the strings it will be used for the concatenation. So let me show it on the SciLab. So this is the shortcut available on the desktop. Double clicking or opening this. So the version latest available of the SciLab is now it is 5.5 is there also. So what we are writing, I'm showing to concatenate these strings, right? So write within double quotes, welcome, right? So what is returning? Welcome to SciLab. Means what is written in the string, that is written in the double quotes, concatenated by the plus sign, and then it will be written to welcome to the SciLab. Right? Now creating functions. Why we create functions? Or what do you mean by functions? Function means a set of lines which are to be repeatedly used by the main program, that we put in a function in a separate notes editor window in a separate file. Because that has to be called by the main program again and again, then instead of writing all these lines in the main program again and again, then we write those lines or put those lines under the name of a function. So main program has to call that function. The provision is there in MATLAB also. So in MATLAB what we are doing, the difference between MATLAB function and SciLab function is that in MATLAB function we have to save the function with the name what is given to the function name. Right? Means we are saving the file of a function. Function name is area C, that I will show you. So area C, Then in MATLAB I have to save that function file with the name of the area C. Only then it will be taken by the MATLAB. But in SciLab that is not there. If the function name is area C, you can give any name to that file. It will be called by the main function also. So this is the one difference between MATLAB and SciLab. Then another difference is that in the MATLAB function, you don't have to write AND function at the end of the function. There is a syntax AND function without any space, right? But in SciLab, you have to put AND function in the SciLab. So this is the main difference. And for the SciLab, you have to write the program in another window and you have to open SciPad, right? Write the SciPad on the command window. A separate window will be open up. Write your function on that file, save it, then execute it. In MATLAB, you don't have to execute the function file. But in SciLab, you have to execute first the function file, then call it in the main program. ठीक है? MATLAB में क्या होता है, हमने फंक्शन लिख लिया, फंक्शन को सेव कर दिया, बट हमने एग्जीक्यूट नहीं किया. SciLab में जब तक हम उसको एग्जीक्यूट नहीं करेंगे, we can't call it in the main program, right? So the method of opening the SciPad or the editor window is either click from the main tab, main menu, or write the SciPad or editor within round brackets and in the command window. So the window will open up, write your function there and start working. And the extension of these files will be .sce or .sci. Generally the functions means when you save the function, it will automatically save in the extension of .sci. The other main programs are stored in the SCE. Only the functions are with the extension .sci, right? Now how to write a function? To begin writing a function, type function. किसी भी फंक्शन को लिखना है, सबसे पहली लाइन क्या होगी? Function, then within square brackets write out1, out2. Means what the function is giving out to the main program will be written in those square brackets, right? Area return कर रहा है, क्या कौन सा variable क्या return कर रहा है, that will come here. Then equal to name of the function. Then within round brackets int1, in1, in2. In1, in2 means what is the input being given by the main program to this function. If you want to calculate the area of a circle, then what will be the input? Radius. Output will be area. These are the inputs and outputs. Then write the body of the function. What we want to calculate, all the calculations will be written after that. Then at the end type end function to indicate the end of the function, right? So this is the main design of how to write a function. Similarly, there is a comment lines. We have to sometimes add comment lines. Comment lines are used for the debugging also, and also when we are writing a code, just to mention it for the future what we are doing or what this code is doing, we write in the using the slashes. So in SciLab the comment line is given by the slashes, double slash, and in MATLAB it is by the percentage, right? Now this is an example of function. Function A is equal to area CR, right? Area A return हो रहा है, radius क्या दे रहे हैं हम? R दे रहे हैं, and A is equal to क्या होता है एरिया सर्कल का? Pi r square. Pi we are writing with pi is a special constant, so we are writing it with percentage pi into r square, right? Then end function. And in the main program we have to call it using only by the name of the function. Area C, provide the input, right? Let us do it. Let me open the SciNotes. So this is the window of the SciNotes, right? you can write here function within square bracket, but we are returning A, that is equal to area C, then A is equal to pi r square percentage pi into r or C into square, right? Then end function. Execute it with the name area dot sci, right? Save it. Then in the main program, let us say on the command window you are writing area, give the radius 3. You are written with 28.274334, right? So similarly, this is a one line program of function. The function can contain many lines, and similarly you can call the function in the main program by giving the inputs, required inputs. And also this is, now here the input is only one. If there are many inputs, right? Let us say we are inputting length, breadth, width, height. 4 inputs are there. Then we have to pass the inputs in the same sequence only. If length is given first, we have to write the length first, then breadth, then width. So this you have to find the sequence of the inputs variables which are being provided in the function only. The same sequence we have to maintain while passing the inputs to the function. Clear? Now inline functions. Those were the functions I have told you the example which we are writing in the another file. Now there are some means, as I've shown you, the area of a circle is a one line function. Why to write in another file? We can write the same function in the main program also. Those functions are called as inline functions because they are very small one line functions that can be called in this same program, only to write in another file. So SciLab allows to have functions in the main program also, and it is useful when the body of the function is short, and that can be possible with the command def. So for that what you have to do, write def. Def, when you will write, the SciLab will understood that yes, it is a function in the main program only, right? def, rest is same, within round brackets, double quotes, A means area which is been given by the function, equal to area C, round bracket R, right, comma, then body A is equal to pi percentage pi into R square, then S is equal to area C2. Means S is equal to area C2 is in the another line, is in the part of the main program. Whatever it is written in the round brackets, that is taken as the inline function. After the command def, as you can see here, after the command def, it is written as in the round brackets, only that is taken as in the function only. After that it is written as S is equal to area 2, means now it is the part of the main program. Then another function example is there, def, within round brackets, then square में क्या है, B, volume of R. So first line indicates, or the first term indicates that yes, the function is going to calculate the area or the volume or what it is going to do. After that, the body of the function, right? Now here we are not writing function or the end function. Rest is same. Clear? So rest the main program goes on the same way. Now the user defined variables. User defined variable means the variables which are being defined by the user only. Means This is user-friendly program we are making. So it is written as means x is equal to input, enter your name, comma string. So whatever is written in the double quotes, it will be displayed on the main command window. Enter your name. String, what it says, that the entered value will be a characters, right? Then y is equal to input, enter the age, right? So here we haven't mentioned what type of data is going to come. It is by default, it is numbers. But in case of string, we are writing string. Then whatever it is being input, process on it, then display the output by using the command disp. Clear? So let us do it. On the SciLab console, the result is being displayed. But when you are writing the program, so prefer it to write in the Sci notes only. So this is the new window will be open up when you write. Here you can write your program. Then in the same way as you do in MATLAB, run, execute. Here it is execute. There was the word run. So from the this keyboard you can also enter F5 for executing the program, right? So but we are writing here in the command window only, but you prefer to write the code in the side notes. So what we have to do, y is equal to input right. So when you enter it, execute it, means when you enter it will be executed. So the what is displayed on the window? Enter your name. So you enter your name, let us say if the font size is visible to everybody at the remote centers, please tell. Remote centers.
Ma'am, could you please write the instructions in the top of the screen instead of writing, because that is not
Okay, okay.
visible to us in the lower one.
Okay, so what I request, because it's writing the program, therefore, whenever there is a problem in the font size, immediately you tell so that it can be taken care. Okay. So whenever you see that there is a problem of font size, please let us know so that the font size can be enhanced. All right.
So there is a command also CLC for the clear console. The command window will be whatever written in on the command window, that will be cleared. So we were doing enter your name, comma string. String you have to write in the single quotes. Yes, yes, yes. Input, enter your name, and the whatever is entered, that will be a string.
Excuse me, madam.
Yes.
Ma'am, the left hand side of the portion is unable. We are unable to see the left hand side of the portions. It is coming starting from double quotes enter alone. We don't know what is in the left hand side of that like enter the strings.
Param. Okay, okay, fine, we are doing.
The left hand side we are unable to see, ma'am.
Okay.
It is coming not input NPUT. We are unable to see x equal to input, but we are starting from nput. That's it. We are unable to see x equal to input.
Okay, fine, we are doing, correcting it.
And also, most probably, ma'am, in last few lines, if you are preventing writing all those lines, it will be good. Because in last few lines, it has been blocked by the like various nodal images in the bottom. If you write in the comments or the top pages, top of the lines, top of the program, it will be good.
कौन सी वीडियो? क्या नहीं दिखता?
सर अपनी ना जो वीडियो आपको दिख रही है बड़ी वाली वीडियो जो दिख रही है उस पर डबल क्लिक कर दीजिए. डबल क्लिक ऑन द बिगर वीडियो यू आर वाचिंग.
Okay, sir. Okay.
It is fine now.
So can you display that previous the x equal to input? Can you display so that we can see and?
The previous one.
PPT show
Previous
करें.
one.
Okay, sir. Okay, it's good.
Double click the bigger scale which you see, because once you double scale the click, then it will be full screen for you.
Okay, sir. Okay, sir.
Okay.
Okay, it's coming good. Thank you.
Okay, thank you.
Okay. So I have entered x is equal to input, enter your name, comma string. Then the display is enter your name. So enter, here it's, I am entering SciLab. Now next is display x, means whatever is entered that is stored in the variable x. So when you display this x, so the displayed value is what you have entered earlier, SciLab. Similarly, y is equal to input, enter the age, right? So when you enter the age and then display the display y, here I have also written age equal to, means here now the answer will be displayed like this, age equal to whatever you have entered age, right? As I am showing, earlier we have entered the name. So now in the display, the displayed will be name equal to SciLab, right? So means the variable x, whatever value it is containing, that will be displayed after this name equal to the variable or the content stored in that variable. Then saving variables. We have entered, we have done so many means programs, coding we have done, manipulations we have done. Now the results are there in the variables only. Let us say a is equal to, example is given, a is equal to I2, 2 and b is equal to 1, 2, 2. So two matrices of 2 rows and 2 columns we have generated, and these are being saved in the variables a and b. Now we are saving this file. This is the file being saved by using the syntax save within single quote a.b.dat. A-b means this is the name given to the file with the extension .dat, comma a comma b. A comma b means in the file name a-b, the variable's value a comma b will be saved, right? So in our program we have got the output, let us say a and b. We want to save it for the future. When we save the a and b in the variables in the form of in the file, then the a and b are free to use in the another programs also. So if we don't save and use those variables for the another program, then our calculated result in the earlier one will be lost, right? So we are saving the data, and then when it is required, we can retrieve that data by using the command load a-b, dat. Now where it will be saved? it will be saved in the present working directory or the of the SciLab. So that can be known from the command pwd. pwd means present working directory. That will give me that where I am saving the that file, right? Let us do that. If a is equal to, I am not putting semicolons, then you will see whatever it is entering. So the matrix is 1 0 and 0 1, right? And b is equal to, let us say zeros or ones, or random, let us say random 2 comma 2. The two matrices we have generated, A and B, random, and this is I with the diagonal elements 1. Now I have to save. How to save? Just write this. I'm just copying it from there. Now it is being saved. Let us see it is being saved in the SCI gateway. Let us better do it. Change directory. Change directory to, right? CD होता है ना उसमें. Right, now let us see. It has not been changed. Means we can also change the directory by using the change directory. cd or chdir command is there, right? Then give the path within round brackets and then change the directory. Now when after that you save anything, that will be saved in the another path, means the path or the file or the space you have providing to the SciLab, only of there only the file will be saved. Desktop. Okay, leave it. So next is logical operators. There are logical expressions, true, false, whose output will be coming. So the logical operators are equal to. So here we have to write 2 times equal to for the logical operation equal to. Means equal to means when we are comparing two variables or the two things, then we have to write double equal to. Not equal to, then greater than equal to, less than equal to, greater than, less than, and not. So if a logical expression is true, what is being written? Either T or F, right? Either 1 or 0. Now the if statement in the main program. We are using if statement for the condition. If this is this, do this. So the design or the syntax is if, write if, condition body. What is the condition? If E is less than 0 or less than 1, whatever condition you are giving, then perform the or the execute the lines which are given in the loop only. Then after the if, you have to write the at the last end. Means the command lines within the if and the and will be executed if the condition is true. If the condition is false, the lines within this loop will not be executed. Similarly, there is a nested if also. One if is there, inside that if there is another if, means there are many conditions inside one condition. So to write those if condition 1 body, then in that body there is another if, then its body, then its end, then the main end of the main condition. So there is an example, CLC is for clear console. Similarly, there is a command CLF. CLF is for clear figure, right? Close, CLOSC, that is not there, but you can note it down. CLOSC is for close the windows. In the MATLAB it is close all. Clear, CLEAR. Clear is for clearing the variables. Whatever the stored in the variable, that will be cleared. So here is an example, CLC is for clear console. We are putting y is equal to 25. If y is less than equal to 18, here we are using logical operator. We are checking. If y is less than equal to 18, then display DISP respects your elders. Else if means if first condition doesn't match, then go to the second. Else if y equal to 20 means now we are checking if y is 20, then display do well. Else display be honest. And means at the last, what the last command says, what the last else says, if the first two conditions are not met, then you have to display be honest, right? So let us execute this program. So I have written this program in the Sci notes and executing it. So when you press the execute button, it will automatically say you to save it first. So I am giving the name of save. Side by side it will be executed. So the displayed one is be honest, because I have given the input y is equal to 25, right? So means I have given the input y is equal to 25. First condition is false, y is not less than 18. Second condition, y is equal to 20, it is also not equal to 20. So the last is we have to display be honest. So similarly here what we can do, we can also get this y value inputted from the user also. So here we can write input age or enter a number, right? Enter a number, say any number. 12, sorry. So I am entering 12. So the result is, message displayed is respect your elder, right? So y is less than 18 means the number you have entered is 12. It is less than 18, so the result message displayed is respect your elders. So similarly we can make our program user friendly also. We can get the input from the user and then process on it, display the output. Next is the for loop. The for loop is for what? If is for the condition, for the checking the conditions. Now the for loop is for the execution of the lines for a number of times. So here a counter is there. We have to initialize the counter and the counter will go on incrementing, and when the final value will be reached, the loop will be, or the program will come out from that loop, right? So the structure is for variable, right? For, then variable which is being assigned to the counter. Let us say I, we are using it. So for I is equal to initial value, from where the counter has to start is to step, or you can also skip this step, is to final value. Let us say for I is equal to 1 is to 10, means the counter will start from 1, will go up to 10. Then body of the loop. Body will contain the various processing and various instructions, and at the end of the command will be I is equal to I plus 1, because we have to increment the counter also. After the first execution, increment it. Second execution, again increment it. So the I value is go on increasing. So when it will be reach 10, it will be executed. The time it will enter equal to 11, then it will come out from that loop. Then at the end, write end. Then another is while loop. While is also a condition, means while and for. We have done condition and for loop, means if and for. So it is while contains both if and for. Mean it will check the condition. If it is true, it will go on executing the loop. Now here the number of times the loop will go on being executed is not known to us, right? So it depends upon the condition. When that condition is met, then the loop will stop, or the execution or the main program will come out from that loop. Clear? So we have to write while within round bracket condition. What we are writing? Normally condition can be, an example is a condition of an error. In the case of optimization problems, we are minimizing or something or maximizing. So if we are minimizing the error, then we have to check the value of the error. The value of the error should be less than according to our specified value, what we are specifying in the condition only, right? So when that error goes below that the specified value, the main program or the program will come out from that loop, right? Then end. So this is an example, CLC E equal to 0, right? N equal to 1 while E is less than or equal to 10. N equal to N plus N into 2, E equal to E plus 1, then end. Now here what is the condition? That E is less than or equal to 10. जब तक वो 10 से कम है वो एग्जीक्यूट करेगा इन कंडीशंस को, एन की वैल्यू कैलकुलेट करता जाएगा, और जब उसके बाद हम क्या कर रहे हैं, ई को क्या कर रहे हैं, इंक्रीमेंट कर रहे हैं, राइट? देन एट द एंड व्हेन द ई वैल्यू गोज बियॉन्ड 10, इट विल स्टॉप executing those lines, right? So this is the while loop, right? This is the displayed. Actually, I have written the command disp n. N is the value which is being calculated in that program, right? So I have displayed n. Here I can also display the value of E which has been attained. 11. जैसे ही वो 11 हो गई, that loop stops, right? So the basic commands I am actually telling you. Display all these things which will be helpful for you writing the programs also. Otherwise, there are so many syntax, so many commands are there, which you will learn when you go deep into it. Otherwise, it is not possible for a single person to learn all these SciLab commands, right? So it depends upon our application, our requirement. What we have to do, what is our requirement. So according to that, we are using those commands. But just I am giving you a start on the SciLab. Next is the break and continue commands. As the name suggests, break means to come out of the loop suddenly. Then continue means if some condition is met, continue or go to the command given in the program, right? So here the syntax is CLC E equal to 0 and equal to 1, the same program I have taken. While E is less than equal to 10, N is equal to this. Now, as you have seen, the N value was very high. Now there are two conditions, the condition on the E and a condition on the N also. Earlier there was condition on only on E. The N value was going very as much as it is going, right? But here I have put on the condition on the N also, that if N is greater than 500, then break, right? Then when it is break means it comes out of the loop, then it will be executing the command display N and display E, right? Let us execute this program also. There is a shortcut control N for the new sign out window, right? Here N is equal to 7 to 9. When it reaches 7 to 9, after that I have displayed the value of N. That's why it is now N is equal to 7 to 9 and E is equal to 5. Means after 5 iterations or after 4 iterations, the N value was going beyond 500. Then it comes out of the loop. Means break command works after E is equal to after the 4th iteration. Here. Now coming to the graphs, means now we have to plot something, right? So the plot functions are different form depending upon the input arguments. Now here is an example given, t is equal to 0 is to 1 upon 100 is to 2. Means t is being given a value starting from 0 up to the final value of 2, and all these will be multiplied by pi with a step size of 0.00, 0.01. Then y is equal to sine of t. Plot t comma y. Then x label within single quote time, y label single quote amplitude, title single quote sine wave. X label will do the labeling on the x-axis, y label labeling on the y-axis, title will for the title only, right? So what this is doing? This is doing the sine waves generation is there, and we are also plotting that wave. It may be there in the right. So this is sine. Save it. This is a graphic window showing the sine wave. One cycle it is being shown, right? See, this is time, amplitude, sine wave. Everything is there similar to the MATLAB. You can also save this window, right? Graphic window export कर सकते हैं you can, and also you can print. Page setup is there. Tools are there for the zooming. 2D 3D rotation is also there, like this, right? So we have used the command plot. Plot is there also in the MATLAB, right? Actually, there is a very slight difference between MATLAB and SciLab. This I have shown you. Now here is another example. X is equal to line space 1, 10 means from starting from 1 to 10 with 5 elements. Then X is equal to, Y is equal to line space 1 to 20 with 5 elements. Plot X comma Y. Then X set window comma 1. Now another graphic window will be opened up using this syntax, X set. Then plot 2D, X comma Y style equal to 3. Style equal to 3, what it will be doing? It will be changing the color of the graph with black line, with green line, with red line. So you can use numbers here as we do in MATLAB also, right? Same is there. Plot 2D is equal to X comma Y comma style equal to 3 RECT. These are the x-axis rectangles. 1 comma 1 means the x minimum. Then another next one is y minimum. Then x maximum and y maximum. Then another way to write the labels. X title. Earlier we were using X label, Y label, then title. Here you can write X title with double quotes, write graphs. Then X axis, then Y axis. So first is the title, then X axis label, then Y axis label. Right? Actually, I have saved it, so let's directly run it. Yes. So this is the code. See, this is graphic window number 1.
Excuse me, ma'am.
Yes.
Ma'am, I'm from Radbara College, Hoshiarpur.
Yes.
Ma'am, the screen and the programs that you are showing are not clear, not visible.
This one?
Yes, ma'am.
The font size is small?
Yes, ma'am, the text is blurred.
Yes, if now it is visible.
Yes, ma'am, it's visible.
Okay, I am using magnifier, so I am going from line to line, okay? So here for the first line is X is equal to line space 1, 10, 5. What it is saying that we are creating a vector of 5 elements starting from 1 to 10 and Y is equal to line space 1, 20, 5, right? So the value is going from 1 to 20 for the Y. And we are plotting X comma Y. Then X set window comma 1. Now this is for the another graphic window. Then plot 2D X comma Y. Now here I am showing you all both these graphs. What is the difference between plot, this single plot and this plot 2D, right? In this single plot we can't change the x-axis and y-axis ranges, right? So we have to write plot 2D for that. And also these styles are being only provided with the command plot 2D. Plot is a linear plot, it is there with the command plot. So we are writing plot 2D x comma y comma style equal to 3. Style means that it is changing the color of the line. Then plot 2D x comma y style equal to 3 RECT 1 comma 1 comma 10 comma 20. 1 means this is the x minimum, then y minimum means the value starting on the x-axis, what is the minimum value. So it will be starting from 1 to 10. 10 is the y max, sorry, x max, and then 20 is the y max. So on the y-axis it will be from 1 to 20, from the x-axis it will be from 1 to 10. Then x title. X title graphs. Now in this command we are giving the x label, y label and title. All three are given using the command x title. Earlier we were using x label, y label and title. So here x title, first is the title of the graph, then x axis title, then y axis title or label. Then next I have just put it on the in the comments. So first we execute these 6 lines, and after that we will see what is going in the next lines. So let me execute it. On execution, this is the graphic 1, this is number 0. So as you can see in the graphic window, first window, what we were using the command plot x comma y, right? So here you can see the starting is from 1 and here it is from 0, means y axis is from 0 and the line is starting from this, because in both the cases we are given 1 to 10, 1 to 20 and the 5 elements were being there. Now in the second window, when we are given the style equal to 3, first see the change in the color, right? Green color is now there, and also this. We are given the minimum values and maximum values also. So it is x-axis is starting from 1 and also y-axis is starting from 1. So this way we can give the ranges for the minimum value and the maximum value from the x-axis side, right? And the command was used was plot 2D, right? In the MATLAB we are using figure round brackets for the generating another figure. Here we are using Excel. Figure we can also use in SciLab also. So these are the graphs which we were getting. Next is the CLF. CLF means clear figure. Window will be there. Graphic window will be there, but figure will be cleared. Then subplot 2, 2, 1. What is subplot means? We are now dividing the graphic window in various sub windows, right? Subplot 2, 2, 1 means a window of 2 rows and 2 columns now will be generated, right? 2, 2 means 4. Now we will having 4 windows of graphs on the single window, right? And subplot 2, 2, 1 means we are going to plot in the first window. The first window we are going to plot, and the command we are plotting is plot 2D. Then subplot 2, 2, 2, plot 2D2, then plot 2D3, plot 2D4. By default, some waves will be generated. Now, what is the difference between these two? Plot 2D, simple plot. Plot 2D2, it will be generated in a discrete form. Means as we are using stem function in MATLAB. What happens in stem? Discrete values are being, not continuous is there, so discrete values will be plotted. Then plot 2D3, the plot will be in the form of vertical graphs. Vertical bars will be coming in the plot. Means you are plotting sine wave, then at each point there will be a vertical bar will be there. Then 2D4, it will be coming in the form of arrows. So the plot is same, only the style is different. That is the difference between all these commands. 2D2, 2D3, 2D4. So this I was showing, yes. इसी Now, one thing you can note down, if you want to do commenting of a number of lines, then use the command Control D. Put the comments for a number of lines, then use the Control D, and if you want to remove the comments, then Control Shift D. Right? So all these comments are simultaneously removed from all these lines. See, this is the graph from the subplots. This is the first graph, as you can see. This is the second graph, plot 2D2, right? This is plot 2D3, vertical bars. This is plot 2D4. Here is an arrow is there in the lines. The graph is same, only the styles is different, right? So by writing the command close, all the figure windows will get closed. Next. So what you are feeling about SciLab? Is it similar or how much similar? What is the difference? It is similar to C? No, you have used MATLAB, worked in MATLAB. Then it is similar to MATLAB or it is similar to C? Similar to both. Okay. So actually C is also being used for the MATLAB. So this is the graph we had obtained. Then 3D surfaces graphs are also there. So by using the command plot 3D, x, y, z. So 3-dimensional graph is also there. This is plot 3D graph. This is a very small code. T is equal to 0 is to 0.3 is to 2 pi. Means now T is having the values starting from 0 to 0.3. Sorry, starting from 0 to 2 pi with a step size of 0.3. Then z is equal to sin t into cos t. Then we are plotting 3D, t comma t comma z. So the graph comes like this. So another thing, you can add x title, x label, y label, that I have not written, but you can now in a form, in a position to write all these commands, right? So you are getting 3-dimensional graph like this. Plot, कौन सी command है? 3D. Also in MATLAB we are using up arrow and down arrows for calling the previous entered commands. Similarly in SciLab you can use up arrows also to get the previous entered commands. And also one thing is there in SciLab, you are writing a command. Write the, let us say you have to write sum, right? Just write S, then press tab. The whole list of commands starting from S will be displayed. I'll just show you. Slow down. Any problem up till now? Any problem? परम सर, ये देखना जरा.
Ma'am, can you get hello?
Yes.
Can you get the manual or the documentation any or from the SciLab.org only?
On the website there are spoken tutorials are there. You can go to the IIT Bombay site, you can get the spoken tutorials on the SciLab are also there. And on the site SciLab.org there is also clearly given the differences between the MATLAB and SciLab. Means the commands which are being used in the MATLAB, and similarly with, in contrast to the MATLAB, the SciLab commands are also available on the site also. If net is there, I can also show you that also. I will show you the site of SciLab and also show you the tabs which is giving these differences and commands for this MATLAB which are being used in the SciLab. So I just want to ask anything, any problem up till now? If you are getting what I have taught till now?
Yes, ma'am.
Okay, thank you. As you can, you know, in MATLAB there are various toolboxes are also there. So can you tell me the name of one or two toolboxes in MATLAB? Signal processing, communication, control. These are the toolboxes which are there in the sim electronics. Okay, I have not gone through that toolbox. So there are so many toolboxes in MATLAB. So in the same way, there are toolboxes in SciLab also. We call them modules. So all of you must have installed MATLAB on your laptops or computers. So how much time it takes? Lot of time is approximately half an hour or more, right? So, but in SciLab you will be only devoting only 15 minutes for the installation of the SciLab. Because the size is small, but the requirement of SciLab or the target what we are to meet, it is the same with the MATLAB. But the size is very small. Disk size is very small. So the execution or the installation time is also very less. And for the modules also, you can download any module. In the MATLAB, there are so many tools, and when you are installing MATLAB, you have to install all the tools. But you require only one toolbox, right? But you have to install all the toolboxes. But in SciLab, you can download, means when you are installing, no module will be there in your program, in your setup. But you can download it online, whatever toolbox you want to use, right? And also you can modify that toolbox. You can add to the libraries of the SciLab. You can add to the functions of the SciLab, right? So I'll show you how to download the modules. And similarly to the MATLAB, there is a Simulink is there. What is Simulink? Models are there, blocks are there, like, so you simulate them and get the result. Similarly, same Simulink type is there in the SciLab also. So continuing now, Simulink, the blocks what I've been talking about. So here it is named as Xcos. Right on the command window Xcos, the windows will be opened. Two windows will be opened. One is the palette window and the second is your window of the graphic on which you have to make your blocks. Right? Same as in MATLAB. So here you can see this is atoms for the module and this is the Xcos is written. Click on it. Just shut it down, then again start it. See, this is the untitled Xcos window and this is the palette browser. So there are various blocks, commonly used blocks, then this is continuous time blocks, control signals block, and discontinued, discrete time systems, mathematical operations, electrical blocks are also there, right? Integer, zero crossing, ports, signal routing, then signal processing blocks, implicit annotations, sinks, then sources. So all these blocks are available for you. You just drag it and place it on the untitled window. Let us say from the sources we take this sinusoid generator. Just drag it and place it on the untitled window. Like this you will get this. Then take this square wave generator, or let us say first going with sinusoidal generator only. Then with this sink you need a CRO, right? This is a C scope. Drag and drop. On the sources side, as you can see, there are two inputs for the scope. One is coming as the input and another is for the synchronization. That is, a clock has to be connected. One thing is there is a different color for these inputs. You can see which block will be there. Here it is red, this is also red. Now how to connect these? Just place the cursor, it appears to be green. Drag a line to this. a hand comes and a green color comes, then release it, right? Now the line is okay. Clear? Next, connect from this to this. Just okay. Right? Now how to configure it? When you double click on the any block, this parameters window will be opened. Now it will be giving sine wave generator. It will be having three parameters as we know: magnitude, frequency and phase. You can change the magnitude to, let us say, 5. Frequency you can change. Then phase you can change. After doing, click on OK. Then click on the scope. This is the color output window. This you need not to change this. Just see the Y min and Y maximum. So Y min is minus 15 and plus 15. What you have given at the input is plus 5 volt amplitude. So that it will cover. So no need to change anything. Just check the refresh period. It is 30. Put it equal to 10. Buffer size, let us say 2. Okay. Come to this clock. Period is 0.1. Installation time, let's say 0. Initialization time, sorry, right? Then go to the simulation, setup, put it equal to final integration time, put it equal to refresh time was 10, we have put in the arrow, put it equal to OK. Then save. When you will save it, what name to be given? Test. Right? Save it. Then start execution. Simulation in progress. You will get this sine wave. Right? So this is the output of this CRO. You are generating this CRO from this sinusoidal generator, and I am just showing you on the CRO. Right? In between there are also various blocks. Mux is there, Dmax is there, square wave generator is there. Right? So all these blocks you can use according to your application. Put the change the specifications, change the parameters, right? And you can use the blocks accordingly. Clear? Then there is one thing I want to tell you. There is a user-defined function. Blocks are there. Means you can also define your block. In SciLab you are making functions. I have told you. You can use that function or call that function in this block. Right? How you can use it? Just let us say we are using sinusoidal generator. From the user defined function, pick this sci-func block. Sci-func block. Right? Right? Now, for this sci-func block, double click on it. If you are to give input equal to 1, output 1. If you have to increase it, just put semicolon here, then 1, 1. Means now you will be having 2 inputs, then you can increase the number of outputs also. Right? So in our case, we will be having only 1 input, let us say in our example, and then no need to change anything else. Right? Click on OK. So this will come. This window says what function you want to call in this block. We have only made area, right? So there is a function, I have already made it, scare u1. Okay. Then OK, OK, OK. In the next 3 windows, just click on OK, OK, OK. Right? Let us Let me see if the name of the function I have given is correct or not. Scare it, right? I also have to write it. Okay, I have to just write here it. Now here the output will be y1, u1 will be the input. Okay. Right? Just join these. Right? Now through the sinusoidal generator you are giving a sinusoidal of magnitude 5 volts. Right? So when you scare it, how much you will get? 25. So just change the parameters of y min and y maximum. I am taking it to be 30-30, right? Okay. Run. Nothing is coming. Either there is a problem in the function. Let us go back to the function what we have created. Scare it. Function s is equal to scare it u, s is equal to u square and function. So this is the function is okay. I've written it okay. Right? So let me execute it first. Yes, this is the problem. I have to just first execute it. Now let us see. See. So I am getting a sine wave of amplitude 20. 25 cent, right? So the amplitude input is 25, input was 5. I use the user defined function in my block. So I am calling the function which I have created in the block also, right? So this way you can write your own functions or own programs, call it in the blocks and then find the output. Clear? So this was the example given. So you can use many blocks according to your applications. Signal processing is there or whatever you want to use. So this is another advantage of this user defined block. Yes. So this is user defined function in Xcos, as I already told you. This is sinusoidal generator. This is the function shared. And this is mux. Similarly, you can use mux. Mux is for the using if more than two inputs are there and the same scope is there. You can now view the shared input as well as original input on the same scope using the block mux. Right? You can also add in number of inputs to this mux also by double clicking on the mux. Just put the number of inputs 1, 2, 3, 4, whatever you want to take, give to it, right? This is the output from the CRO, means the original and the shared way also. Now with two inputs and outputs, as I've already told you, if you are using one input or two inputs you are using, you just have to add 1 comma 1 semicolon, then again 1 comma 1. Similarly, for increasing the outputs also, you can increase the outputs. Now atoms. This is the module manager. Means for adding the modules. What you have to do, just click on the SciLab console. This is brown icon is there called as atoms. Click on it. This window will be appear showing the all the modules which are available. Aerospace, contributed, SciLab, binaries, data acquisition, data analysis, GUI, education, image processing. All these modules are there. But you and on the right side list of installed module on your computer, right? So after that, click on the module you want to download. Click on it, this window will appear. Then here this is remove tab, install tab and update tab, because updation will be also be there, right? So just click on the install, your module will be installed on the site. So now you are not being provided with all the modules at the time of installation, but you can download the module which you want from the net, right? But for this, net connection is required. Now comparison to MATLAB. I think I should ask this from you people. What you think? What are the comparison or similarities and differences between the MATLAB? There is a difference in the functions, right? You have to write end function at the end of the function. Then the name of the function can be different to the file name where it is being saved, right? File extensions, yes, they are different. And then, yeah, commands on the graphs, stem is there, stem is not there. For the stem there is plot 2D2, right? Then yes, we can import MATLAB functions. We can even translate MATLAB code to the SciLab code. There is a tab on the SciLab console also. We can also translate MATLAB code. Then another command line. On the command line, in that we were using percentages. Here we are using double slashes, right? Another, the time consumed is less in the installation, right? Cost is 0. Internet cost is means downloading cost is there and nothing than that. You can modify the source code. The source code is available to you, but in MATLAB it is not at all available. All the modules are with means you have to install all the modules in MATLAB, but in SciLab you can download your own module only. Or then the size on that disk is very less. And the size of the setup is less. Yes, one more thing is there. Inline functions are there in MATLAB. You can write DEFF by writing the DEFF. Then there are predefined variables are there in SciLab by using the percentage, prefixing the percentage. So these are the some of the similarities, advantages and disadvantages. So the most important क्या है? The SciLab is freely available. This is the very much important. Though it is slow than MATLAB, less commands are there as compared to MATLAB, but it is fulfilling our motive. It's for the students, for the some small industries which are working on it. So it is fulfilling their objective. It is freely available. That is the biggest advantage, right? So this is the basics of MATLAB and some of the basic programs we have done up till now. So in the next session we will be doing the programs of error backpropagation and particle swarm optimization, PSOs. Right? So there will be a tea break for how How much? Okay. Sir will tell. Tea break for? Okay. Now there will be a tea break for 15 minutes. We will again join at 11:50.
Excuse me, ma'am. Excuse me. Can you hear me? Excuse me, ma'am. Can you hear me? Are you listening my voice?
Yes, yes, please.
Ma'am, I am from JCR University.
Okay.
I wanted to ask a question about the differences of SciLab and MATLAB.
It is
You told me that difference between SciLab and MATLAB. SciLab and MATLAB.
SciLab and MATLAB. Yes. What do you want to know?
On the basis of applications, can we differentiate SciLab and MATLAB?
No, no, no. We can't differentiate on the basis of applications.
Suppose for the optimization, I am using genetic algorithm.
Yeah, there is a neural network and optimization module is also there in SciLab. You can download it also.
Okay, so for the genetic algorithm, which is better, SciLab or MATLAB?
For the genetic algorithm, both are better, but SciLab is freely available.
Okay, only this is the difference.
Yeah, yeah, this is the difference.
Okay, okay, thank you.
Okay.